All right, today we're going to look at simplifying radicals that have different index numbers besides 2. So we're no longer looking at just only square roots. We could be looking at cube roots, fourth roots, fifth roots, and then we're going to be doing some addition and subtraction with roots as well. So we're going to start with simplifying. So we're going to do a factor tree like we did when it was the square root, but there will be some catches along the way. So let's keep going, and then we can talk about the changes as we go. So once again, use your calculator, find any number that goes into 486. So I'm going to go with 2, and 2 will go in there 243 times. 2 does not break down, so leave that alone, but break down 243. That'll go 3 and 81. 3 does not break down. 81 will go 9 and 9. And then each 9 will go 3 and 3. 3 and 3. And then here's one of the new difference. We used to say when it was a square root, you were looking for pairs, but now we're no longer looking for pairs, because if you look here, our index number is now 5. So this number right here, that tells you how many have to be in your group. So now we're looking for 5 of the same number. So in this problem, we're looking for 5 of the same number. So no longer 2 of the same number, but 5 of the same number, because my index number is 5. So then I would look, I say, look, I have 1, 2, 3, 4, 5 3s. So that means I get to put 1 3 on the outside of the fifth root. And then your single number, or ones that you do not have a group of 5 of, they go on the inside of the root, which is my 2. So remember, group number goes on the outside of the root, and singles or leftovers go on the inside. So I'm just going to call them leftovers. So leftovers go on the inside. Whoops, sorry. Leftovers inside the root. But now this problem also contains some variables. So now we need to chat about our variables as well. So the first variable we have is a to the 8th power. So you want to think, how many sets of 5 can I get out of a to the 8th? So for the first one here, I'll kind of draw it out for you. So a to the 8th means I have 8 a's. 1, 2, 3, 4, 5, 6, 7, 8. So then how many sets of 5 can I get? So 1, 2, 3, 4, 5. And hopefully you'd say, oh, I can get 1 set of 5. And how many leftovers do I have? I have 1, 2, and 3 leftovers. So I get to put 1 A on the outside, and I have 3 A's left on the inside. Okay, or you could think of it as, how many times does 5 go into 8? It goes into 8 1 time, and then you would have 3 left over. Okay, and then if I have B to the 14th, then I would think, all right, well, how many times does 5 go into 14? And then I would say, oh, okay, well, if I took 14 and divided it by 5, that would give me 10. So I know it goes in there 2, so I would have 2 on the outside. So 2 B's on the outside. And then I would have to take 14 minus 10, which would give me 4 left for the inside. And then for C's, I have 5 C's. So then I would think, oh, well, 5 goes into 5 one time. So I would have 1 C on the outside. And then 5 minus 5 is 0. So then that means there would be 0 for the inside. So no C's on the inside. So then to help me write my final answer, okay, for my plain numbers, we said we were going to put a 3 on the outside. For the A's, we had 1 group, so I get to put A on the outside. For the B's, we said we were going to have 2 of them, so that would be a B squared. For C, we said we were going to have 1 of them on the outside, so that's just C. And then we have to have our 5th root. Please make sure you put a little index number of 5 there. On the inside, our plain number, our leftover number, was 2. For the A's, we said we had 3 A's left over, so that's going to be A to the 3rd power. For B, we said we had 4 B's left over, so B to the 4th power. And C, we said there were no C's, 0 C's, so do not write down any C's on the inside, and we are done. Okay, so let's go try another one. Okay, for this one, let's break this down with a factor tree. So 4 and 324. 4 can go to 2 and 2. 324 is 4 and 81. 4 goes to 2 and 2. 81, 9 and 9. 3 and 3. 3 and 3. And then remember, what's our index number? Our index number is a 4. So we're looking for 4 of the same number. So I've got 4 2's and I've got 4 3's. And I don't have any single numbers. So to me, it looks like I would have a 2 times a 3, which would be a 6 on the outside. And then I do not have anything that goes on the inside of the root because there are no leftover numbers. So now let's go to our letters. Okay, A to the 8th. Well, how many sets of 4 can I get out of 8? Well, I can be like, ooh, well, 4 goes into 8 2 times. So that means I'm going to have 2 on the outside. And 4 times 2 is 8, so that means there will be 0 on the inside. Okay, 17 for B. Well, 4 will go into 17 4 times. So that would be 4 on the outside. And 4 times 4 is 16. And 17 minus 16 is 1. So then I would have 1 on the inside. For C, 4 will go into 12 3 times, so I'll have 3 on the outside. And 4 times 3 is 12, so that's 0 on the inside. And D has 3. Well, 4 does not go into 3, so that means I cannot put any on the outside, so 0 on the outside. They all have to stay in the inside, so they have to stay inside, all of them, because I cannot pull out a group of 4 if I only have 3 of them to start with. So then my final answer, on the outside for my plane number, I will have a 6. For the A's, we said we were going to put 2 of them on the outside, so that's A squared. For the B's, we said 4, so B4. For C, we said 3, so C3. And for D, we said none of them, so don't write any D's. And then we have 4th root, so make sure you put the little index number of 4. No plane numbers. We said no A's, 1 B, so B, no C's, and all of the D's, so D to the 3rd. And then that makes your final answer. Okay, so now let's go to simplifying that we have adding and subtracting. Now, the first thing you have to know before we jump into these is what is considered a like term when you're talking about roots. So if you have a like term with roots. So a like term with roots. So it's kind of like a twofold thing. 2 things have to be true. So you must have the same index number, so that's the same number outside the root, you know, that little bitty number typed up above. And also, the second thing that has to be true, they must have the same number, so there's my little number sign, inside of the root. And if both of those are true, then you will combine their outside numbers. So here's an example. So example, if I have 10 4th root of 3 minus 3 4th root of 3. So the first thing you have to look at is, oh, they both say 4th root, boom. Then they both have a number 3 underneath it, boom. So if those are both true, then what you're going to do is you're going to look at the outside numbers, which are 10 minus 3. So 10 minus 3 is 7. And then you will keep the 4th root of 3 attached to it. So think of the 4th root of 3 like an x. If you had 10x minus 3x, you would call it 7x. So it kind of works the same thing for a root. But to combine roots, they have to have the same index number and also the same number underneath it. Okay, so now what we're going to do is when we look at the problem, you're going to notice that they're not all have the same index number, and they don't all have the same number underneath. So I would start the problem by first trying to break down the number inside the roots. Okay, so let's start with 20. So here I would do a factor tree for 20. So I would do 4 and 5. And 4 breaks down into 2 and 2. Now this problem, you'll notice it doesn't have an index number. If it doesn't have an index number, that means it's a square root. And if it's a square root, the index number is a 2. So now we're looking for pairs. So I have a pair of 2's and a leftover 5. So that means I get to put a 2 on the outside. But what number is already on the outside of this square root? And that number is a 5. So what I'm going to do is bring the 5 down, and I'm going to do 5 times the 2 I put on the outside, which makes 10 square root of my single number, which is 5. So 5 square root of 20 changes into 10 square root of 5. Now go to the next term, and we have 16 underneath, so let's break that down into 4 and 4, and then each 4 goes to 2 and 2. This time my index number is a 3, so we're looking for a group of 3, and I have 3 2s, and then I have an additional leftover 2. Okay, so I'm going to bring this minus sign down, so I have minus, and then I get to put a 2 on the outside for my group of 3 2s. Then I have the third root, and then my single number is 2. Okay, going to the next one. Break down 250. I'm going to go 25 and 10. 25 is going to go 5 and 5. 10 is going to go 5 and 2. My index number is 3, so I'm looking for a group of 3, which is 5s, and I have a leftover 2. So then I'm going to bring down this plus 6, and then I'm going to take 6 times 5, which would make plus 30 on the outside, and then I have the third root of 2. And then the last one, I have minus, and then the 5, I can't do a factor tree for that one because it would just be 5 and 1, so I'm just going to bring that straight down. Okay, so once I broke everything down with a factor tree, now I want to identify which ones are like terms. So I can put square roots and cube roots together. So I'm going to identify the square roots together first. And for my square roots, I have 10 square root of 5. And then at the very end, I have minus a square root of 5. So I'm going to check. They're both square roots. Do they have the same number underneath them? And the answer is yes, they both have a square root of 5. So they are considered like terms. So look at the coefficients in front. So I have a 10 minus 1, and 10 minus 1 is 9. And then I just keep the square root of 5 attached to it. So I have 9 square root of 5. Then let's go over to the cube roots. I have negative 2 cube root of 2 plus 30 cube root of 2. They're both cube roots, check. They both have a 2 underneath of it, check. So they are considered like terms. So combine the front numbers. So I have negative 2 plus 30, and negative 2 plus 30 gives me a positive 28. And then keep the cube root of 2 attached to it. And then remember, a square root and a cube root are not like terms, so do not try to go any farther. This is your final answer. It does not matter to me which one you write first. You could write 28 cube root of 2 plus 9 square root of 5, or you can have it the way I have written. Okay, so the last one, we're just going to try this over again. So we're going to start by breaking each one down with a factor tree. So I'm going to do 27 and 5. Then I'm going to do 9 and 3, 3 and 3. And then my index number is a 3. So I'm looking for a group of 3, which happens to be 3 with a leftover 5. So I'm going to bring my negative 2 down, and I'm going to multiply that by 3, which makes negative 6 cube root of 5. Then for the next one, factor tree, I'm going to do 6 and 42. 6 is going to go to 2 and 3. 42 is going to go 6 and 7. And 6 is going to go 2 and 3. This root doesn't have an index number, so that means its index number is a 2. So we're looking for groups of 2. So I have 2 2s, and I have 2 3s, and a leftover 7. So I'm going to bring down my 2, so plus 2. And then I'm going to multiply that by a 2 and a 3, which gives me plus 12 square root of single number, which is 7. Factor tree 40, which is 4 and 10. 4 goes 2 and 2. 10 goes 2 and 5. My index number is a 3, so looking for groups of 3, which is a 2. Single number is 5. Bring down my 4, so I'm going to take a positive 4 times 2, which is plus 8. Cube root of my single number, which is 5. 7 I can't do a factor tree for, so I'm just going to bring this straight down. So I have minus 6 square root of 7. Okay, so this time, just to show you it doesn't matter, I'm going to start with the cube roots. So I have negative 6 cube root of 5. And then on down, I have a positive 8 cube root of 5. So cube root of 5, cube root of 5, so those are like terms, so combine the front numbers. So negative 6 plus 8 gives me a positive 2 cube root of 5. And then look at the square roots. I have a positive 12 square root of 7 and a negative 6 square root of 7. Square root of 7, square root of 7, like terms, so combine the front numbers. 12 minus 6 is a positive 6 square root of 7. Then remember, a cube root and a square root are not like terms, so that's as far as you can go, and you are done.